Hello, my name is Joshua O, and for this research project, I focused on developing a web interface that can assist in identifying trends in user data. This summer, I've been working with my mentor, Samuel Moran, and my undergraduate mentor, Matthew Aragon. My sponsors include Sandia National Laboratories and the O-REU program, provided by Texas A&M. Human beings are hardwired to look for patterns. This is how we've survived up till now, and how we continue to progress. In a sense, we can be seen as living databases, extrapolating information from our surroundings and using our experiences to survive. With the innovation of the computerized database, our ability to organize and store information has progressed even more, leading to the creation of programs like Microsoft Excel. Imagine that you're using Excel to manage data. Depending on the size of your dataset, finding specific information can be difficult. Like our own minds, it takes time to search for the information that we want. Now imagine tapping into a database magnitudes larger than an Excel spreadsheet. With the massive amount of data stored, a user will have to search meticulously for what they seek. You would probably want tools and features that could easily organize and locate specific information. With this in mind, my research group's objective is to take user analytics data from the Granta materials database and identify data trends for developers. To solve this problem, we must first organize our data. Otherwise, it will be difficult to identify trends. Second, we need to display our organized data in useful ways. The graphic on the right is an example of this. If our data is presented in a meaningful way, then discovering trends in our data will be much easier. The hope is that developers can use the data trends found to develop new features for Granta that caters to its users. You may be wondering, what is the Granta Materials database? Granta is a commercial tool for storing materials data. It is used by all the national labs and by other government agencies and commercial customers, like NASA and Boeing. Granta stores a variety of information, hosting several reference material property databases. In the example shown, elastic modulus is the main focus, but there are many other properties, such as density and shear modulus, that could also be shown. In addition to reference data, Granta also stores data produced by Sandia and other members of the nuclear security enterprise. A typical example of this could be the materials modeling and testing data for a nuclear weapons safety switch. Now here is our web interfaces that we ended up with. Next, I want to show the code that helped construct this. For this project, I'm using the Python packages dash, pandas, and plotly. Dash allows me to write HTML, hypertext markup language, within a Python algorithm, while pandas and plotly are used in conjunction to create and display database information. Furthermore, I am using CSS, cascading style sheets, to make the web interface visually appealing. Here is my CSS sheet. Now back to the Python algorithm. This Python algorithm constructs a proxy set of user analytics data and presents this information neatly in a web interface. So all the information that you will see once the web interface is open is fake at the moment, but it is constructed in a way that the actual data taken from the Granta Materials database can easily be ported into it. Now let me run you through the code. At the top, you can see all of the different packages that I have imported for this project. Right over here, these are different arrays of information that I am using to construct users to create a fake database. If I move down, here's a for loop that's creating each individual user and adding it to a pandas database to be used in the construction of each of the graphs. And if I keep on moving down through this code, eventually I get to the area of the code where I'm creating each of the graphs. As you can see, I'm creating the Gapminder graph, which I will be showing you momentarily right here. And if we move down a little bit more, here are the scatter plots that are being created, the bar graph, and the heat map. Now if I continue through this code, here is the code for creating the dynamic sidebar, which shows at-a-glance information. And if I continue down, here's the HTML that is constructing the actual web interface. Now if I open up the web interface, you can see the at-a-glance on the side, As you can see at the top, there's the divisions, and you can see that there are 10 of those, centers, and then groups. And those are just the individual organizations that are using this database. Furthermore, this at-a-glance bar shows the group with the highest average total hits, which for this particular set of proxy data is the group 5880. If we move down, we also have the total yearly database hits, which is incremented and shown here. And finally, we also have our total unique yearly users, which shows 91, which means that there would be 91 users that have used this database in the last year. Now, if we move over here to the Gapminder graph, the hits per division, we can see that the information is grouped by average hits per month and total hits per month. Each of these divisions are shown, and with that information, we can see the change in how many hits per month and the average hits per month over time. If I move this cursor, it shows the difference for each of those divisions. You can also animate it using this play button. Now, Plotly has a cool feature that allows me to turn off different divisions or isolate one of them so that I can see how it changes over time. Now, if we move on to the usage over time graph to the right, we have the same feature where you can turn off different parts of the graph. This is useful for isolating information if you want to identify specific parts of the data. You can also click and drag to look at smaller areas of the graph. You can always reset the axes by going up to here and pressing the home button. Now this graph is supposed to represent the amount of hits over time. As you can see, there are many different plots for the amount of hits, and the red line is representing the rolling average over a 7-day period. Now moving to the graph on the bottom, we have our hits per database graph, which shows each proxy database and the amount of hits that the database registered over the course of the year. If we move on to the division center heat map, this graph shows the frequency of hits per division. The higher up the red value is, the more hits per division. There are always more functionalities that we could add to this interface, so we hope that as we continue its development, Sandia and other national labs can use the information gathered to develop better features for the Granta database. Thank you for watching.